Okay, welcome to another video about magnetism. This one is about how you can make magnets and also how you can break magnets. And what I mean by that is, how can you make something that is not currently magnetic into a magnet? And then how can you also make something that is currently a magnet lose its magnetism? All right, so that's our questions for this video. There's several ways to go about doing this. I'm just going to focus on two ways for each, making and breaking magnets. And they're going to center on these three things. One is using other magnets, another is using a hammer or striking of, of the objects, and then the third is using electricity. And you can actually make and break magnets using electricity. This is a picture of a solenoid, which is simply a coil of wire that's hooked up to a power source. So, let's get started. Alright, here we have first way to make a magnet. Alright, so I'm going to focus in on this solenoid up here. And I've put a little magnetic symbol over it. This is just to show the magnetic field in the solenoid. It's not actually part of the solenoid. The solenoid itself would just look like this, this down here, right here. All right, so looking at this picture again, what we have is a steel bar that's going to be inserted into the solenoid and then left there at rest. Then we'll turn on the electricity for a while, leave it there for a bit, just sitting inside the magnetic field, and then we can turn it off. And you want this to be reasonably strong current, but doesn't have to be super strong. And then once you've turned off that electricity, this is what happens. You're going to take that bar back out again after you've turned off the electricity, and it's going to be magnetic. And in fact, since the north end of the magnetic field we said was here at this side, then this side of the bar will actually be the opposite. A north pole is going to induce a south pole. So this side of the steel bar that we can see still kind of inside the coil, that is going to be a south pole, opposite to the north that induced it. All right? And then when you're done, basically you have a semi-permanent magnet. Yay! Why does that work? Well, it works because the solenoid sets up a magnetic field within and around itself. And that causes the steel to take on the characteristics of that, or to be influenced by that magnetic field, and it makes it into a magnet. All right. Well, is there another way we could make a magnet? Let's see. This is probably the simplest way to make a magnet, actually. It's quite easy, and I've done this one many times myself. Essentially, you take something that's already a magnet, you figure out what its poles are. So I've got that overlaid here on this stack of neodymium magnets that we have here. Actual image of some neodymium magnets, and I just said that this end is the south and this end is the north. You could find that out using a compass. But basically we'd take the same steel bar that we were using before, and if we take just this south end and rub it back and forth, or take the bar itself and rub it against that magnet there, just this half, not the whole thing, just this end here, what ends up happening is this, right here. When you're done, this end is going to be a north pole, and then that by default that means that this end will be a south pole. Even though we didn't do anything to this end, it's still going to be a south pole because this end became a north pole. Interesting. All right, that's it. Again, we're using a steel bar. Why steel? Because steel is a material that forms permanent magnets, whereas iron would only form a temporary magnet. So that about wraps it up for the two ways that I want to talk about of making a permanent magnet. Now it's time to move on and talk about breaking magnets. Okay, so the first way I want to talk about breaking magnets is also by using electricity. So here we're going to use a solenoid again, but this time we're not using direct current. Before we had direct current DC. This time we want AC. We want alternating current inside this coil. And alternating current is also going to set up a magnetic field, but that magnetic field will constantly flip poles. So at one moment this end is north and this end is south, and then the next moment this end is north and this end is south. So it's constantly in flux. The magnetic field is constantly switching back and forth and back and forth and back and forth, and that's going to totally confuse the magnetic properties of this steel rod. Mix it up. It's constantly, at one moment is trying to make this end a north pole, and at the next moment is trying to make this end a south pole. So in the end, it's just going to scramble all of the little magnetic domains inside that steel bar, and you'll end up with a plain old piece of steel that's not magnetic anymore. So that is one way of breaking something that's already magnetic. Another way of doing that is by hammering it or hitting it a lot with something that's a solid object, like a hammer, obviously, is a good choice there. So if you strike a steel magnet with a hammer, you're also going to scramble up the magnetic properties of the steel. So this is steel that's magnetized. You hit it a bunch of times with the hammer all along its length, and when you're done, you're going to have a plain old piece of steel that's not magnetized. Because what you've done, again, is mix up all of the domains inside there so that they're not arranged in order anymore. There's no the magnetic domains are still in there, but they're all disorganized in all different arrangements. So there's no north end and there's no south end. It's just a regular piece of steel, and that's how you demagnetize something that's magnetic. You can either strike it and cause it to lose its magnetism that way using a hammer, or, as we mentioned before, you can put it into an alternating current solenoid and leave it there for a bit, and that should also scramble it up and demagnetize it. So there you go. This video has given you 2 ways of magnetizing a steel bar and 2 ways of demagnetizing a steel bar. One that I didn't mention is that you could heat steel. If you get it hot enough, that's also going to scramble the magnetic domains. And also one other way of magnetizing a steel bar would be to hammer it inside of a magnetic field that is, what do you call that? Fixed. So a DC, basically a magnetic field produced by a DC solenoid or some other constant magnetic field that's not changing, has a clear north and a clear south. Then you can hammer the steel inside that magnetic field, and that will also produce a magnet as well. So there you go. Anyways, ultimately I showed you with diagrams and stuff 2 ways of magnetizing and 2 ways of demagnetizing. And then I just mentioned a couple of other ways, one more way of magnetizing and one more way of demagnetizing that are a little bit harder to picture. So anyway, I hope that's helpful. That's basically what you need to know. There's 3 ways of magnetizing and 3 ways of demagnetizing a piece of steel. So that's it for this video. Thanks for watching, and we'll see you next time.